See the Wentz displacement law here we know that black body will be any object that can absorb or that can emit radiation. Radiation जो absorb तो गंबा emit तो गंबा तो कोई नहीं तो black body को अपना तो here this is a black body and let us consider this black body. This black body is maintained at a temperature T. Temperature T is maintained and it produces radiation in all directions. So minor radiation here. And according to the given diagram, we have 1, 2, 3, 4, 5, 6, 7. 7 radiation is being produced from this black body maintained at temperature T. And let us decide the wavelength or let us decide the color. Color says red in the color. This is red. This is also red. This is also red. This is blue. This is yellow. This is green. And here this is again red in the color Z. Other how many radiations are being produced from this black body? Radiation means it must be in the form of photon. Photon it must have a color, and every color of the light comes out with different wavelength. Is that understood or not? The simple way from this black body, which is maintained at temperature T, it produces 7 radiation. The total number of radiation produced is 7. But out of this 7 the maximum number of radiation is in the spectrum or is in the color of red, blue, violet. This is for your red. Understand the here the maximum number of radiation produced is in the range of red wavelength. Red wavelength here in your Wentz displacement laws, the is a very simple concept. The maximum see red have zero red confusion chalani. Then we put it as violet and again. This is your violet. This is also again violet. This is also again violet. This is again violet in the color C. Out of this 7 radiation produced, the maximum number of radiation produced is of violet color. Okay, so violet color की तापरा मान Wentz displacement on high is the maximum number of wavelength, maximum number of radiation produced will be inversely proportional to the temperature of the black body. This is for Wentz displacement law. Understand the wiko? Simple way having is the maximum number of radiation produced. Maximum number I'm not talking about the magi wavelength that discuss if we compare the wavelength of 7 basic color compared to the red will have the maximum value. We are not talking about the individual color discuss we are talking about the quantity. Quality is violet ka simple this is violet. Vibgyor and we have already studied this Vibgyor and the maximum wavelength will be for your lambda r and the minimum will be for your lambda violet. We are not discussing about the nature of the color or nature of the light. We discussed the we are just simply discussing about the quantity of the radiation. The quantity of the radiation produced will be of violet for this particular example. Understand that? The maximum number of radiation produced will be in the wavelength range of violet key wavelength key range and this is inversely proportional to temperature, or in simpler language the maximum number of radiation produced will be inversely proportional to the temperature in lower level. If temperature is increased, your wavelength of the maximum radiation will change. The maximum number of radiation is for violet color. Now, if the temperature is increased, it will change to another. For the understanding you for another consideration, we still have 7 layers. 1, 2, this is 3 libra, this is 4, this is 5, this is 6, this is 7. Violet cannot change the red. This is red, this is red, this is again red, this is again red, and this is green. This is blue, this is your violet in the color zero. The simple in the maximum number of radiation produces changes to our rate of change. So, Yan Taita de Nang is home the bro. Tangiko, and simple logic time Harry said, temperature is inversely proportional to the maximum number of radiation produced, and this maximum is with respect to the number of radiation, and this is not with respect to the wavelength. Wavelength natte ko understand torba classroom sida 100 student lay rewa si 100 student lay sida ngasi di kano banina kano ngasi mandio basina boys ngata la ekhalazeba natra girls ngata la ekhalazeba. Out of this 100 student nangi 90 is kano re ekhalazeba girls ne ekhalazeba yarba yare ko girls la adu itaradi this girls second ke that is lambda maximum number of student in the class is girls ne have abra. Next another day dum tila change tawreba hata no boys na 60 la adu girls na only 40 la khalazeba adu itardi reverse separation tabra. When the number of boys increase, number of girls decrease. Yeah, na adu chamanana here the maximum number of radiation produced will be inversely proportional to the temperature. If temperature increase, then wavelength of the maximum radiation will also get changed. And if you still do not know the concept what I am talking about, then forget everything. For the radiation chapter, if there is wavelength mentioned the only law that is included in your heat chapter that contains lambda, that contains your wavelength is for your Wend's displacement law. So you forget everything and you just remember this is lambda equal to this is b by t. You simply write like this. Aduga the lambda 1 by lambda 2 is equal to t2 by t1. You have to remember this one. Next, if you do not know what I am explaining, you simply have the concept of wavelength included in your Wend's law. Wend's displacement law is the wavelength. You remember wavelength is included in your Wend's displacement law and it is inversely proportional to the temperature for a black body radiation. Finish. Next, we will discuss the next Newton's law of cooling and what do define cooling? This will be the last formula. Newton's law of cooling. Cooling defined yesterday. I have already defined you that cooling means it should be the fall in the temperature. Cooling is the change of the temperature with respect to time. The temperature is decreased. What was the first step? There will be loss of heat, and due to that loss of heat, temperature will be decreased. And decrease in the temperature is known as cooling. Here, very simple. Our cooling it for a black body, for any black body, not a grey body, from your point of view, Stephen point of view, the Stephen law, the Rf is equal to sigma A m s t power 4 minus t naught power 4 minus I discussed I will be differentiating the two formula. This is also cooling. See cooling from our Stephen law, and we will discuss cooling from our Newton's law. We will discuss the from Newton's law of cooling. We have any object at temperature T and the surrounding temperature is maintained at T naught and heat will be continuously exchanging in between the body and body exchange surrounding the exchange. Now simple is your dt by dt, that means the rate of cooling is directly proportional to the temperature difference T divided by T naught. The temperature difference between the hot body and the surrounding will decide how fast the cooling will occur. Gyan tabra koi sida di koi di this is non tropical subtropical region sing idna subtropical region ai di this is hot region atro. India is relatively hot as compared to the polar region. Nangi Antarctic natraga Arctic desert patadi very cold idna adu nangna Arctic region chala kan cha de 100 degree level thalo no puthoga boil to na sara haju matamda after 30 seconds it will turn into ice ta thalo turn to ga to ni however koi sidadi koi gi kan sidadi the tropical region sidadi na gi cha de boil to haju matamda it will take at least 10 minutes to cool down. Do you understand the concept here? Why is it so? Kali moktama ani difference kai legi no, because nangi already it is the temperature of the surrounding is at minus 10 degree or minus 20 degree. So the temperature difference is quite huge. There will be repeat cooling. To the heat loss due to the repeat loss in the heat, their cooling rate will be very fast in the polar region. However, in our tropical region, our temperature difference is very low. Our rate of heat loss will be low. Rate of heat loss slow. As the heat loss is slow, the decrease in the temperature will be also slow. A temperature decrease to slow. Our cooling is slow and high. Basically, cooling is directly proportional to the temperature difference. That is the simple logic. Understand the this is the statement. This statement is not going to be used for our formula. For calculation point of view, we are not going to use this formula. Simply combine logo tare. Let us consider the body. This body is at 95 degrees Celsius. Initially, the temperature of the body is initially at 95 degree due to the loss of heat to the surrounding. Surrounding the loss of the T final becomes 60 degree. This is T equal to 10 minutes. I need concept. Very simply, I am not discussing about the temperature of the surrounding. I just discussed about the temperature, decrease in the temperature of this hot object. This hot object was initially at 95 degrees Celsius and it cools down to 60 degree in 10 minutes. 10 minutes tamaze decrease the temperature of the surrounding is temperature of the surrounding is 30 degrees Celsius. Then very simple. Will the cooling continue or will it stop after 10 minutes? Do you understand what I am trying to say? Man hari say 95 midna 95 to 60 the cool down to 10 minutes changeva. Surrounding temperature is 30 degree ne. Will cooling continue or will cooling stop here after 10 minutes? Temperature 60 this is more than the surrounding of bro. Still cooling continue to stop cooling will stop only when the temperature of the body and the surrounding are equal. Do you get the concept here? Next what will be the time taken by the same body to cool down from 60 degrees Celsius to 60 degrees Celsius. This is equal to 40 degrees Celsius. Cool down to what will be the time taken? T2 will be equal to question mark. Simple logically, you don't have to think it very deeply. Initially the body was at 90 degrees Celsius and it cools down to 60 degree in 95 from 95 it cools down to 60 degree in 10 minutes. It takes 10 minutes to cool down from 95 to 60 degree provided that the surrounding is maintained at 30 degrees Celsius. Okay. Now what will be the time taken by the same object to cool down its temperature from 60 degree to 40 degree da cool down to ta ni what the duration man matam kya lagani putho question will be like this ya da already for your Newton's law cooling the they will give you the temperature of the hot body, initial temperature of the hot body, final temperature of the hot body along with the temperature of surrounding. Understood tawra tawi. However, for your Stephen's law nang Stephen's law the cooling calculation from your Stephen's law is that we discuss about a fixed temperature of the hot body and fixed temperature of the surrounding. There is no initial and the final temperature. If no if no initial and the final temperature is given for the hot body, then you have to apply the cooling formula from Stephen's law dagi panudi ba yabra adu natabida karigumba mana temperature je initial temperature piramme final temperature of the hot body je habidi the temperature change of the hot body is given at two different level the period initial temperature final temperature along with the temperature of the surrounding period thirdly you have to apply our Newton's law of cooling pangani and Stephen's law of cooling must be applied only for the temperature of the hot body fixed temperature of the hot body and fixed temperature of the surrounding yarba understood the wong ami I haven't talked about it. That's up to you. No? Then you cooling of the this is change in the temperature happening. Very simple. What is the initial temperature? This is Tin bro. Initial temperature. This will be usually higher minus initial temperature minus final temperature divided by what is the change in the time? T2 minus this is T1 or simply the duration this is T1 the duration this is T1 and it must be equal to for removing the proportionality we have to take the value as K in the lower C this is K any constant K lower mode you can take this to be X in the lower so it doesn't matter how to remember this formula this is important ever. This is statement. From this statement, you have to, you must know how to convert into formulas. dt. What do you mean by this? dt. Change in the value of temperature. Decrease in the temperature. Decrease the initial minus final. And this dt means what is the duration? Initial time will be 0. Final time will be 10 minutes. The duration. Yeah, bro. Change in the temperature divided by duration. Duration is 10. Maintain to ba? Yari ko se. Understand to re? So we write the differential form in terms of initial, final, and duration. Iraba. Yari ko. And for removing the proportionality, we have to put it as x mulapra. Adu di angtang hairo. Do you understand the logic behind here? 95 study. Will the temperature of the body decreases from 95 to 60 in this 10 minutes 95 first minute 1 minute after 1 minute after 2 minutes it maintains 95 maintain after at the 10 minute it is suddenly changed into 60 swine or brand no it keeps on decreasing continuous on decrease I hasn't understand the woman bra. The temperature of the hot body keeps on changing in this 10-minute duration. 10 minute ki duration ta atum hong na tro 95 tagi 94 93 92 91 90 lagi 87 lagi 80 87 85 84 80 79 mana tu decrease to la it keeps on changing na tro nang ai na hining ise 10 minutes sila khangong hong na te ba nang ngasai gi 95 atum lairaga after 10 minutes 95 to 60 the direct home munate man home is kabai lakani 95 tagi continuous oina decrease to draw that means the temperature of the hot body keeps on changing during this duration 10 minute ki duration adum change na we have to consider the average value of the temperature of the hot body must be average value ta do bane average value ta hai ta dike batare initial temperature plus final temperature divided by 2. Do you understand the concept here? magi temperature magi statement is kiri hai temperature of the hot body have natra, but the temperature of the hot body is continuously changing in the given duration. Therefore, we have to consider the average temperature of the hot body. And how to calculate the average? We know the two extreme temperature, initial temperature, final temperature. So if we know the two extreme value, we can easily calculate the mean natra average na. That is why T initial plus T final divided by 2 minus temperature of the surrounding. Finish. Yaraba, statement is how to represent your statement in terms of your Canada formula that we are going to use for our calculation. Anyway, let us do the remaining part of the question. Question radiation is the colony, and from today we will start your kinetic theory of gases. Question number yang asiko. When skip to the question number kya skip to gi. Question number 52 home skip to gi bra. Question number 52 sida yemo. Question number 52 home lai ne. Aduga magi ne aina hiding bomb nei ko. If the question is related to your radiation and it contains wavelength hai content to utara di you should apply your Watt's displacement law, because there is no another law containing your wavelength. Wavelength ngawam ta leite ba. Huna se aduna khangera khangora, if you know if you don't know, it doesn't matter. You have to simply apply your Watt's displacement law once the question contain your wavelength. Wavelength me gawa de dum option law chubodo de dum. Man question da is kai pide. For this question number 52, the temperature of a furnace, and this is a hot object. In hot object, you should know that every hot object will produce radiation. Hot radiation produced with na. Radiating any even the dull color iron se iron ki color se dark and dull iron ki color se dark and dull if we apply heat to it produces glowing effect. Mas glow to red color ki reddish color ka convert to that means if an object is heated object heat to it will produce radiation produced simple logic ni mana say if the temperature of the hot object is 2324 degree Celsius the majority have ni ko I maximum have do language to khitan phajadre the majority harage ko the majority of the radiation produced will be in the wavelength range of kya for wavelength 12,000 angstrom pirala I ask ko and when the temperature of the hot body is at 2324 the majority of the radiation will have a wavelength of violet, red and mayam lakido majority to kana gogi habidi mayam legi se tuan legi ni ba habidi some will be violet, some will be red, some will be green but majority out of this 100 sida majority is 90 go natra 90 will possess the wavelength 12,000 understood torba RSI is who we go habidi maximum wavelength 12,000 only have not majority of the student will carry 12,000 majority of the radiation will have 12,000 as their wavelength. Understand tore? Now makata nam kari hare man hari se if the temperature if the intensity of the spectrum of the star is maximum nearly at 400 angstrom, the simple there is a comparison amani ko pa thori se have the star amana magi maximum majority of the radiation produced will have 400 orbita then what must be the temperature of your star with temperature to kya aata dekhiye indirect comparison ne ba like sikhamra sama na apni sida bola mujhe rakni 273 at of the third gala 7 9 5 2 tabra. So me ko ya 7 9 5 2. Here this is for your question number 52 kya no 52 okay. So question number 52 ni. Therefore mana produce the maximum se kya lani se majority of the wavelength will be equal to lambda majority lambda 1 hamare ko. This is of 12,000 angstrom ne nakhala jeba 12,000 angstrom. Now star amle re ko see stars na mana produce the maximum wavelength se. This is lambda 2. Majority of the wavelength will be in the wavelength of 4800 angstrom. Now tell me mana heading is again no what must be the temperature of the star. Star to be temperature kya aata है कोर्स नहीं था या तबरा अब simple way ना I can imagine don't get confusion over here. First you understand the question. Your Wentz displacement law है. This can be applied for star. This is applied the way and it can be applied for any heated object. This is applied the way abra. Ya iko understood the amigo have a stars look at the way it produce radiation. At the same time your hot object will also produce radiation natra it will follow Wentz displacement law. Your hot object will follow Wentz displacement law as well as the stars it will follow the Wentz displacement law. Understand the way? This will be also lambda 2, this will be also lambda 2, this will be also lambda 2. How many? This is also lambda 1, this is also lambda 1. That means what I am trying to say is that majority of the color, majority of the radiation produced will have or will possess 12,000 angstrom, and majority of the radiation produced from this particular star has wavelength equal to 4880 then what must be the temperature of the star? We cannot calculate the temperature of the sun. Sun ki temperature ko calculate to humra namde. However, in our scientific journal we have the temperature of the sun to be around 5,000 to 6,000 degrees Celsius. How do we calculate that? Have we reached the surface of the sun? By using this formula, we calculate indirectly the temperature of the sun or any star. Okay, this is a very simple way now. Lambda 1 by lambda 2 is equal to, we know that this is inversely proportional. This is T2 divided by T1. Remember the relation. Okay, they are inverse proportional. We must add lambda 1 by lambda 2, T2 by T1. And what is to be found out? T2 is to be found out the drop. Here lambda 1. What is the value of lambda 1? 1200 divided by what is the lambda 2? This is 4800. And what about your temperature T1? This is 2597 and this is our temperature T2 and this is in terms of CE 400 cancel chakra ko 4800 cancel chakra 12 4 1230. This is equal to 15 divided by. You calculate this at your home. This is in terms of Kelvin. From I hide one lay for. The temperature is specific on a piram bataragadi. If the temperature is specific on a pirava, 10 degree, 20 degree in a pirava, you have to convert this into Kelvin converter and fine. After getting the answer, it must be again converted in terms of degree Celsius converter. However, if we consider the change in temperature change the consider we don't have to change it. Temperature to convert next time we go. Question number 58. Mana pili say yung question number 58. Let me do you question number 58 amaga dalawa iko lagi say 58 amaga 61 amaga ko lagi. Question number 58. Two spherical body two spherical body A and B M P record A C के radius से क्या हो दिनो 900 को सीमा न पीरी से सी की bracket siga 9 siga di adum kanoda koi kaya nang keyboard di thangai dana number the seven ko 9 natte ko it must be the radius of the sphere A is 6 centimeter hangani ko and that of your sphere B set mana P is the kya pyramid 28 and P that 28 must be converted into 18 the converter amana kya pire 6 centimeter pire atopa maduna kya pire 18 centimeter ama pire ko and what are the temperature of the body A is maintained at T1 and that of B is T2 ne khalasi ko the maximum number of intensity that means majority of the wavelength majority of the radiation produced from A is about or will have wavelength about 5000 nanometer and there will be isna 1500 nanometer or then considering them to be black bodies what will be the ratio of the rate of total energy radiated by A to that of B. Question number 58 we have two black body, one is of radius r1 is equal to what is the magi radius kya no this is 6 centimeter and pibra 6 centimeter ma pire and another atopa maduna what is the radius r2 is of mana pire say this is 18 centimeter ma pire and the temperature is T1 and this is temperature of T this is T2 in the khalasi how to calculate the energy produce kya kamai matkani if we know the temperature of our black body we can easily calculate how much of energy will be produced in the form of radiation by Stephen's law temperature khamu ta report pe apna tro our total radiation energy produced will be equal to if this is E if this black body has a temperature T over then what will be the total radiation energy E is directly proportional to T to power 4. This is Stephen's law na tro. Kya tay ko? Mana se area mo pila mapina we can easily calculate this is Q divided by AT is equal to T to power 4 mo hai bro. Yari ko. Or here Q by T will be equal to kya mana ni? This is sigma or we have already defined this as sigma AT to power 4. We have discussed this in your Stephen's law. What is being asked? Man hangi se kayo no? Radiation produced by the first body divided by radiation produced by the second body is to be compared matra but for the application of your total energy produced we have to know the temperature je final to mthau changra sangi adu di ain haning is last we have already discussed all the three formula or three law that is included in your radiation the energy is kana dewi energy is included only in your Stephen's law heat energy is included in your Stephen's law na to and what about your Wend's displacement law it talks about only wavelength and temperature na ta what about your Newton's law of cooling it talks about only temperature na ta adu itadi heat wave harata dine if the question contains radiation energy or radiation heat, you have to apply your Stephen's law. Do you see the application or do you understand how to apply these three different law? Hangi ko heat ko yaw taraba radiation energy yaw taradi you have to use our Stephen law. Nang Stephen law do apply to bane energy hek hamtar Stephen law temperature hamtar kana it may be from your Stephen law dagi hambayai or it may be from Wend's law dagi hambayai or it may be from your kanadagi Newton's law cooling dagi hambayai and wavelength garagana it will be only Wend's displacement law RS khangani ko in harija yari ni adu di here man hangi se selection kadang ye gasi kya pyramid se lambda 1 is equal to magi dadi 120 nanometer and pibra so 120 nanometer hai bora La la brain piece 500 pibra. Sorry, this must be 500 nanometer. So 500 nanometer, and this will be your lambda 2 से क्या आता है 1500 nanometer में pibra pire. अभी दी very simple way ना. When's displacement was a final torsic lambda 1 by lambda 2 is equal to this is T1 by T2. That is 500 divided by 100 nanometer get cancel out ratio albanina. You don't have to change it into nangi standard unit ta convert to na ta dekho 500 temperature T1 by T2 ma hapasi cancel chakro. This is 1 by 3rd amtabra 1 by 3 yare ko se ma ye bhi kya kari 1 by 3 ko ne ko yare T1 and T2 will be kanana temperature higher will be heli temperature is higher for your sorry mistake sile record. This is T2, this is T1, because Well's displacement load it is inversely proportional tabra inverse proportional with the here this is 500, this is 1500 into this is T2 divided by T1. So this will be 1 by 3rd malapra like the temperature of the bigger black body is lower. T2 से क्या लोग बता रहे हैं? We have to consider it to be 1 and T1 की value से क्या लोग बता रहे हैं? This is 3 हम लोगों ने lower drop lower निको. Now since we know the कना खंगे temperature of the black body खंगे temperature of the second black body खंगे and what about the area? We can easily find out the area of the black body खंगा निको. Area of the black body खंगे and simple way ना the heat energy emitted will be Q1 by Q2 is equal to this is A1 by A2 into this is T1 by T2 raised to the power 4. Do you understand this? According to our Stephen's law की heat है का रदी के नाता depend on you just look over here सिद्धांत नहीं इंदिरो heat is directly proportional to area. Radiation energy is directly proportional to area and the temperature the temperature which is not given we calculate it from Well's displacement law. And what about the area? Area is already given indirectly in the form of radius R1 and R2. Okay, hanga niko happy law, and we know that area when spares the 4 pi r square ni the 4 pi get cancel out, and we can take this to be nangi kamani where this is R1 by R2 raised holding square into T1 by T2. You calculate this at your home. Are ready? क्या कतरा? R1 की values ना क्या 6 apiro, R2 की values ना क्या apiro. This is 18 apiro 1 by 3 हंगबरा हंगे. You will get the answer. RS answer क्या आता है? हाँ. 9 type of सुमेरमान है जे. Answer should be 9. Option number 1. तो यूं चला बोलो को. Next question number question number 61 से मान फिर इसदा we have your T1 lambda 1 पे देखो T2 lambda 2 मान हम इसे कहीं ना lambda 2 is to be find out. Very simple. You go through the Well's displacement law. Hey, ready ko? Hey, has he abread the bro? Krishna Kanta Khandrabo. Question number 61. The man Hari said a black body is at a temperature 200 Kelvin. Is to be is found to emit a maximum energy at a wavelength of 14 micrometer in a period. That is very simple. Majority of the radiation produced by this black body at 200 Kelvin set will have 14 micrometer produced. However, when the temperature is increased to 1000 Kelvin, what will be the new wavelength of the majority radiation? majority do handakti the new wavelength will be about what range kya da lakani. You simply apply lambda 1 by lambda 2 is equal to T2 by T1. Yagadra? Understand the record? Temperature je kai da pyramid mana pyramid je Kelvin da pyramid natra. You don't have to change it. Yani yagadra yarodro yare ni. And the next question is question number 64, 65, 66. The question number 61 though, no, you try to zero, you try. Question number 61 yourself at your home the nang to zero na. Next question number 64. 64 ne, 65 ne, 66 ne, 67 ne, 68 ne. The last 5 questions there, these are based on your Newton's law of cooling there. Yaga mana yung question there ko yung rough one very quickly na you read the question nung parge mo. Here question number 64 does we have a change of the temperature from 95 to 90 yung pibra 55 to 50 yung pibra. Initial final temperature of the whole body is given. Question number 65 does initial final temperature given. Ad ay mahikagin to high. If the initial and the final temperature of the whole body along with the surrounding is given with that, you have to apply Newton's law of cooling apply to me hamnatra. Understood tawwa? Tawre ko. Yan. Policy ka. Question is the ambient temperature है ना मैं यहाँ पर question is the नंग नखंग तो बस ambient temperature the temperature of the room में ना यहाँ तो question number 65 तने माना पीरी is the ambient temperature is 30 degree ना पीरी दो the temperature of the surrounding ना तरह temperature of the room temperature तो कोई ambient temperature है high गा और सीधा simple है ना माना पीनी इसी question number 65 लोग सीधा 66 लोग सीधा next 10 minutes hai bam yaw anyway low mana bani ko everything low sab mani aduna I will be doing only nangi question number 66 ma ipolage aduga to ko mana temperature of the body and then temperature to ko yung matab to ko yung magwate 65 ne 66 ne ek bol again remaining में आपसे दिन है remaining 3 question will be your homework words याद था आई है जे खंगी को temperature हंगवा मा question can be asked like this what will be the final temperature after cooling ni betul the temperature hangma ma natraga second type ta kamai na pbi kamai hangbi just by giving the magi duration piraga what will be the just by giving the initial and the final temperature what will be the duration mas matam kya answer ni mama anyway question number 65 san bolage question number 65 se the kamina pire what is the initial temperature of the T is the initial temperature जो क्या हो रहा है 80 degree Celsius में पीबरा from 80 degree Celsius it cool down to 60 degree the लेबरा in 1 minute का मास cool down तब रहे the temperature of the surrounding is 30 degree हो रहे in cooling it from 60 to 50 the it will take क्या हो देगी प्रोसेस इधर यात्रा देखो सिंपल ये कैसे हाँ बता ये मुझे सुनो कंधा हाँ ना फॉर्मूला देते ही रहोगे Newton's law cooling the initial minus final divided by duration and this is your K natraga X constant khangani ko aduga mean temperature Ti Tf divided by 2 minus T naught. This was the formula natra khangani ko si familiar with changeba. Now let us consider for the ahan low simple ask you na on 80 to 60 gra 80 minus 60 what is the duration on a same is it now 1 minute for your easy calculation let us calculate in terms of minute and finally after getting the answer we can simply convert it into second on by option this second pyramid na 60 the our multiplication will be multiplication to we simply take it as 1 minute and target for your understanding you na 1 minute in target yani ko sige x sama lai lesi dia mo ko sa anya tori mo je this is x into magi dikalali sa this is 80 minus 6 80 plus 60 divided by 2 minus what is the temperature of the surrounding. My temperature of the surrounding is क्या 30 degree in the this is 30 degree in the divided by next the second case apply to we have to apply for the second case. I mean Newton's law of cooling must be applied for two different changes in temperature, one from 80 to 60 and for the second case it should be from 60 to 50 understand the we go I separate on the later arrest matam mangi time consume to we time consume do other than matam mangi simply now we take the ratio of the two different cases. Okay, yani ko step ani I'm jumping two step step ani je cancel to shorten to ini. Next time we see what is the next change of the temperature. It will be from 60 degree to 50 degree the change to what is the next change in the temperature? It must be from your 60 degree Celsius to 50 degree Celsius and we have to calculate the deviation T2. Understand the right? Now for the denominator or for the second case your x this is x into what will be the change in temperature, your 60 plus 50 divided by 2 minus this is 30 degree. Temperature of the surrounding cannot be changed. Surrounding temperature is changed. So here very simple x can cancel out and we will be having this is 20 divided by 10 20 this will be 20 this will be 10 into 2. Can we have this one? Yeah, this T2 will be in terms of minute talak, di ba? Sida din nang next di kamay mo kita this is 60 cancel sa nang kita di here this is 40 yung tabra. Sida ko 60 cancel sa kaya 80 divided by 2 40 yung nare si cancel sa 25. Understand to ko mga I will see 2 is na si multiply to 60 from edna. Nang nalagay siya 60 minus 60 0 sakre ko IT divided by 2 we are left with only IT divided by 2 ko level it will be 14 rest this samara sakre ni kya 60 get cancel out 50 divided by 2 25 pangaba since you cancel out this is 2 lakh the 2 is the cancel 20 in tarbo here we will be having T2 will be equal to 20 divided by 25 and this will be in terms of minute amalakra. Try the line, answer 20 divided by 25 into this is 60 second amount okay mga okay ko. Ya pa mali ko. Di mga time mga 48 abra. Our answer will be equal to 48 second. Finish. ಯಾಗದ್ರು ಅದು ನೋಯಿನ ಸುಖನ್ ಬದ ಮಾನ ಆನ್ ಸನಿ जे 60 second am changidra question jinang khangadu bamana it is very kaleba tempting to select the option sumaina option the superior mechanism se ose let me give an examples done without any calculation you will be tempted to choose the option this choose the one gane and the 92 IT will be the game say your your cooling down takes place from 90 to 80 degrees Celsius and it takes T equal to T1 equal to 5 minutes next the mana is 80 degree na 70 degrees Celsius ta cool down next T2 will be equal to most of the students will select 5 minutes why because you will develop automatic in your head and automatically develop for every 10 degree decrease for every 10 degree decrease there will be there will be a duration of 5 minutes and then computer develop the and you will choose the answer to be 5 minutes and then select the this will be wrong but you know la liman you consider only the hot object the hot object consider the temperature decrease from 90 to 80 degrees Celsius is only for the hot body see hot body hot body see the temperature decrease from 80 to 70 this will be only for hot body the temperature decrease there must be loss in the heat loss and heat cannot be lost to itself masana I want to heat I want to it must be lost to the surrounding we do not consider the surrounding simple temperature of the surrounding is 40 what will be the temperature difference 50 30 this is 30 the temperature of the surrounding this is 30 temperature difference 60 degrees Celsius like so temperature of the surrounding this is 30 what is the difference 50 quick quick it 7 minutes because rate of cooling is directly proportional to the temperature difference temperature difference is delta T greater is the delta T what is the temperature difference is directly proportional to cooling the temperature difference between the hot body and the cold body is 60 when it is 60 degree it will be very fast when it is reduced to 50 degree your heating your cooling will be relatively slow it will take more time mathangda nang ngasagi 90 degna IT the decrease to 5 minutes changi IT the 70 decrease to matamda 5 minutes changi that will be totally wrong it will be get more than 5 minutes dekhe finish yara abudi nang nasle se comment hagatare you should not choose the 5 minute option just choose the where therefore equal decrease in the temperature yara this concept will be applied for your question number 66 will apply to where yaga anywhere koi maka sa thara jise question number 66 sima torosi aduga we will come to the end of our radiation mana sangi se kala ya 62 50 am lakra 10 minute am changi ko what is the temperature of the surrounding 25 lakra like next man second the ilani se second the yo se question ja understand tapur ngamre a body cools down from 60 degrees Celsius to 50 degrees Celsius in 10 minutes in the first 10 minutes it cools down mana cool down to from 60 degrees Celsius tagina it cools down to 50 degrees Celsius ta indhareba hangani ko aduga mana mo hangisna assuming the Newton's law cooling se valid oy na khanbiro and what must be the final temperature after the end of next 10 minutes yan tare. After the end of next 10 minutes means we have to consider the duration from 11 minutes to 20 minutes. Yaar ba? Hey, understand tawon de. RS khangdrabo. Sida le ise magi duration je karai duration. This is 0 laga. Time se when starting time se t is equal to 0. After the end of 10 minutes matungda what is the temperature change? My temperature change there. The 60 60 to 50 next what would be the final temperature after the end of 20 minutes. Next 10 minutes it must be from 10 minutes to 20 minutes. Next 10 minutes past 10 minutes and this is the second 10 minutes. Is that understood or not? Here this temperature of the final se kya aata hai this is the T initial for the case number 1 for the first 10 minutes 10 minutes ki hoina thi we have to consider 60 degree to be the initial and final to be your 50 degree this is for what case number 1 case number 2 be the for the next or for the second 10 minute duration. For the next 10 minute duration we have to consider the initial temperature to be start from 50 degrees Celsius. Si mo go do bane yagadra yan taita de ngang je kangani ko side tani na khali da sibu yan ta hun radi ai ira nate 50 minus tf divided by what is the next 10 minutes. This is 10 divided by this will be x and this will be your 50 plus the final minus this is 25 divided by 2 and this get cancel out 10 get cancel out and we are left with 10 divided by 50 minus the final and this will be this get cancel out we will left with 30 divided by CC cancel chakro the df divided by 2 lembra. Si understand tawong ambra kam dabre mo si understand tawi ko sina si chakre ko si multiply to di ka 50 pangedra 50 cancel chakre na df by 2 lemo na ba ini si solve to biro Gane ko natin isipin mo sa kapilan question number 67 na you have to calculate the value of T naught की value को follow आएगा hey देखो now we will start your kinetic theory of gases शायद लोई से heat की portion लोइसला बनी को heat की portion लोई है heat की portion है जिधर दी हाँ तो फिर आई तक rewind करके को कन्वर्जे chapter से हम सॉल्व बनी ना तो ड्रीम मैप जे हम कॉपी First, we will discuss the temperature. Discuss the ani subada heat capacity natraga the specific heat capacity will be for your entire body, and specific heat will be for one single unit mass. Next, the third now we discuss our conduction, the mode of heat transfer, conduction, and fourth topic the radiation. And in this radiation we discuss three different laws. What is the parameter that decide the amount of heat? Temperature. We discuss problem based on your temperature. Next, number 2, the quantity of heat. Quantity of heat will be decided by two factors. For the entire body, it will be known as heat capacity, capital C, and for one unit mass, it will be specific heat. Question based on that we have discussed. And once temperature decided already, heat ki khange. Next, the third type we have the transfer of heat in two different ways. That is included in your syllabus: conduction and radiation. We do not have your convection in your syllabus. Now we will discuss about kinetic theory of gases. Before concluding our transfer of heat se a glass filled with water so this is hot water, 100 degrees Celsius. What will be the mode of heat loss? What is the mode of heat transfer to the surrounding? Surrounding the man heat the loss of the what will be the method? Will it be conduction, will it be convection, or will it be radiation? Do you understand the question? Hot body cold body heat loss of there will be three different ways for a hot body to lose to lose your heat from hot body to cold body. The heat loss of in three different ways loss of in the form of conduction, convection, and radiation. Let us consider an example where we have a glass of water at 100 degrees Celsius, and this 100 degrees Celsius water will lose heat to the surrounding. Then tell me what are the different process or what are the different type of heat loss to the surrounding. Will it be conduction or will it be radiation or will it be convection or RS? The heat loss to the surrounding for this particular example will be in three ways. Number 1, the conduction. Conduction is nangi maktuma half glass the glass is heated. Glass to heat up the still glass no rekana seva. None charge the still glass to my temperature increased. That is, heat is conducted to the container. Understood? Next, heat is lost in the form of vapor. That is convection. Okay. Next, si hot object si hot object we feel heat sensation that is radiation. Understood? So, you should not confine only to conduction, convection, radiation, and single vegan over. A body, any hot object, any hot body will lose heat to the surrounding in three ways. The heat loss, the conduction, convection, and radiation. Understand the now we give kinetic theory of gases stories. What about? No, Wardi, Yararoida. here sida nang khang the p v is equal to nRT. We will discuss this directly when a kinetic theory of gases we will discuss tomorrow discuss the usiko music energy we will discuss your ideal gas equation. PV is equal to nRT where n is equal to P stands for the pressure of bra, V stands for your volume or R stands for the gas constant or T stands for the temperature. So any gas there will be three parameters that decide the condition of a gas. Gas character decide to gas magi condition decide to magi parameter ahumna decide to ganeba. Ahan bada pressure, ani subada volume, ahum subada kana oigani temperature, and we are left with one more parameter manehori, that is quantity of the matter, that is number of mole mala dakar tabra tai ko simuju discuss to ganeb. In short kamai habitare the three main criteria that will decide the property of a gas will be pressure, volume and temperature, and out of these three sigma there will be a little role for the number of moles in hydra. In our physics there are so many n's you change it with mu the change to number of mole mu that's up to you. Understanding you use the symbolic representation. RS, what will be the expression for number of mole? How to find out the number of mole? Come on, find out the mass divided by mass m divided by molecular weight and hydride bro. Gram molecular weight and hydrogen chemistry the gram molecular weight and hydra hypo sikandro gram equivalent answer gram equivalent or gram molecular weight mw umlakra, and this can be also be expressed as total number of molecule or atom present divided by Avogadro number Na. Yagatra sikandro mole concept khangab natro yare ko RS khangani ai explain to dusu yarba yare ko aina karam bache no ai kaure and also the nuclear physics ta I think I have already explained the mole concept. Tak nuclear physics ta takte Lorentz ta tak nei wa ai jam to gramo bisa ngatain tak kira mole concept and Williamson Hamobra. Do you remember that mole concept which I have discussed in your nuclear physics? Anyway, 5 minutes I explain to 5 minutes very simple thing. Here nang is the carbon carbon oxygen what is the oxygen atom oxygen atom what is the molecular weight molecular hydrogen atomic number se kya no oxygen ki hoita thi this will be you write like this is magi atom le this is 16 there is atomic number will be 8 and mass number will be kya la se 16 and this wala natra yan dai ko ado here this is an atomic oxygen amane sigi atomic oxygen sigi what will be the atomic mass oxygen ki mass hai magi mass kya tare this will be equal to 16 AMU hadnatra 16 atomic mass hadnatro understood ngami but this 16 atomic mass in our real life we cannot measure it when a measure to ngam deba therefore this has to be converted in terms of gram which can be measurable in our real life measure to ngam bra I don't know we take oxygen atom je adum lo re sili kya 16 AMU 16 atomic mass until we get kya la se until it turns out to be 16 gram ta we take it yeah bra 16 atomic mass is very very small natra Sigi very small atomic mass unit we take repeatedly adum loreba 16 atomic mass unit is taken repeatedly so that it is equivalent or it is equal to 16 gram which is measurable 16 gram sigi da mass ta de bukuina compile to we collect oxygen atom so that it is equivalent to 16 gram. 16 gram equivalent of oxygen atom we collect under that consideration, under that time when the total mass of the oxygen atom sindo bagi mass na 16 gram what will be the number of atom present? The number of atom present will be equal to Avogadro number 6.022 into this is 10 to the power 23. This is the constant. Okay. Hangabai Harise, Habiti Nangi atomic mass unit chair. This is very small and this cannot be measured. So in order to convert the equivalence I dikhangi ko mag atomic mass unit si gram the convert to gaitari we have to take Avogadro number of the Avogadro number of the atom or atom molecule or molecule ion or ion. Do you get the concept here? Understand the woman because your atomic mass can be converted into its equivalence in gram by taking Avogadro number. Okay? Hamatra? Yani ni. Adu it is simple way na. Nang minor period khalazeva. How to calculate the number of mole? Number of moles se kamina period. Oxygen atom sina oxygen molecule ilaure ko. Oxygen molecule ki molecular weight se kya tani? Our molecular weight will be equal to for one oxygen atom it is 16 namlegra. For molecule magidi kalani for one oxygen atom it is 16. For molecule we have two atom it will be 16 plus 16 it will be 32 32. Question will be like this. We have a given sample of gas containing 64 gram of oxygen molecule. Then find out the number of mole. My number of moles so kya tha find out though. Very simple. It should be the given mass of the sample divided by gram molecular weight of the oxygen molecule. It should be equal to 64 divided by 32 and this will be 2 moles. This is the way how we calculate our number of moles. Nangi number of moles to calculate to process minus calculate to gani given mass divided by nangi molecular weight. Yaradra yareko next time kailani se 1 dozen kita kya yawi 12 pieces yaw natra yareko aduga next time koina 3 dozen amma yaw taradi kya lani se 3 dozen dadi kya yawi this will be 36 pieces yaw idra yaiko adu ita simple oina we do not have this c like rekhala jeba adu ita di we have total number kya lera total number of pens nang kolom machine 36 lay reba adu ita di how many dozens are there. It will be very simple. 1 dozen you cannot Avogadro number de khalo ba adu ita di 36 divided by nang 12 with 30 we have 3 lakh 3 dozen namala idna then they go this is equal to number of mole. Yeah, betul. As we go, number of mole can be calculated either from your mass or from your number. Yeah, betul. We have 24 students over here. Then how many dozens will be there? There will be 2 dozens. Natra in number dollar ko taragati that will be total number of the molecule divided by Avogadro number. Yeah, betul. And you will get our kanalani number of moles. Yani mass piragana total mass of the given sample divided by molecular weight. Yarani is minus tang wala again. Now let us see the basic nangi conversion of PV is equal to M divided by MW. This is RTN ivya bra. Ya tarapose this is the fast form of our ideal gas equation. Next, second formula kami iba tare. Mani is can we have this one? Number of mole can be written as total number divided by Avogadro number. Now this will be converted into Kanamanani and into this is KT. Yan siga ay kau lagi. Karigumba, if the gas constant is divided by your Avogadro number, gas constant do nangi Avogadro number na divide ka butardi, we will call it as nangi Boltzmann's constant ko gani ko. Ya ka simas gap salo ay nagditay se nang nakhangado bisne nangi chemistry da su yawi dana. Chemistry no thermodynamics yawi dana. So hadala to ni ko. We have three different type of ideal gas equation. One containing the mass and the molecular weight, and another another containing your Boltzmann's constant, that is PV is equal to NKT, where N is the total number of molecules present. No chemistry that somebody you study only these two equations. Original the PV is equal to NRT. Mainly on this one and this one. Discuss the PV is equal to M divided by MW into this RT. Discuss the see, you have chemistry that. But in our physics study we have an additional extension of our period. Anyway, let us do your question number 70. Question number 70 done. What is it? I know what is there. Question number 70 question number 73 identical. I will be doing only one. 70. Question number 70, 73. I will give you a question of the paro. You read the question and select one question from your question number 70 and the 73. Ama select all. Question number 70 holra 70 holra karam hologe apa mam khalo Williamson karam hologe 70 or 73 70 mana piris da for your question number 70 we have 28 gram of nitrogen molecule. So N2 nitrogen gas in nature we have monoatomic, diatomic and triatomic molecule layer. The nature of oxygen is diatomic O2 and what about your helium? Helium is monoatomic, diatomic, monoatomic. Hydrogen this is diatomic hydrogen simple we have nitrogen molecule and what was the initial mass? Initial mass we have 28 gram of nitrogen molecule inside a container. And what was the pressure? When the total mass, when the initial mass of the nitrogen gas was 28 gram, the temperature was 57 degree Celsius or Midna. The initial temperature was 57 degree Celsius and there is a hole. Your gas leak out. Some gas will be coming out from that container. Container to the gas escape to grava. Now the pressure due to the escape or due to the leakage of some nitrogen gas to the surrounding, the pressure is reduced to half the reduced and the temperature is also reduced to 27 degrees Celsius. Then what would be the final amount of or the final mass of the nitrogen gas that is left inside the container? Do you understand the question? Initially we have 28 grams. Simple understanding of the question is that initially we have 28 gram of nitrogen, and due to leakage there will be some nitrogen gas will escape to the surrounding the escape the grave, and how much of nitrogen gas is still left inside the container. Yarba, yariko. Use the formula. Be used to PV is equal to question number 70. M divided by MW into this is RT ini ibra. Yang tahu mana kani pyramid pressure pyramid temperature pyramid temperature pyramid bro temperature pyramid na two different conditions, the before leakage and after leakage. Before leakage the temperature was 57. After leakage, after leaking out some gas, some nitrogen gas to the surrounding, the temperature of the classroom or the container reduces to classroom suppose our classroom set has a volume capacity 20 out of this 20 students, 13 has gone. 13 then we are left with 7 students. Do you understand the concept here? While we calculate the number of students that has already gone, remaining is we still maintain the full capacity of the classroom. What is the full capacity? 20 students. First we have to calculate how much of the students have already left the classroom by keeping the volume constant. Container and what to do because as we calculate this mass remains. How many students are remain inside this classroom? 7 students are remain inside this classroom. What was the initial number of students? 20 how many have gone? 13 have already gone. How many students have gone? First we have to calculate, or first we have to count the number of students present inside this classroom. Classroom 7 out of 27, 7 are remain, 13 have already gone. Aduna nangi 7 students these 7 students will be in the classroom. Classroom ki the volume change before the student, before 13 student has left still capacity is 20. After leaving still 20 aduna we have to calculate the remaining mass and colony, and once we calculate the remaining mass we can easily find out leakage mass of the plastic. then we have this equation. See, we have molecular weight remain constant because nitrogen na have natra. Nitrogen is 28 chap manidra. What about the nangi gasagi velocity molecular weight remain constant? What about the volume? The full capacity of the classroom is still 20 before the student have gone and after they have gone. Moi chat ki mamang tu 20 lebra. Sida nangi si b constant tabra. If this is constant, C constant we don't have to use in our ratio. Ratio below right aduna the initial pressure before leaking out, final pressure after leaking out. Hanga niko. And this is a very initial mass before leaking, and this is the final mass which is left inside the classroom or inside the container after leaking. Hanga niko. Aduga temperature before leakage, aduga after leakage T. Yeah, finish. Man, kya P versus P is P1 divided by P2 की वैल्यू से क्या माने? P1 divided by 2 in a hand right bro. You read the question to paro. Your pressure is decreased to क्या था? Decreased हो रहेगा. P1 by 2 में hand रहा है bro. Pressure is reduced to half the reduced हो रहे. And what was the initial mass? 28 gram and we have to find out the remaining mass into what is the temperature. T1 की value से क्या ना? Temperature T1 will be equal to 57 degree and your 57 degree Celsius will be exactly equal to 273 option 0 क्या आता है इसे? This will be 10, 13, 330 था बरा. This is 330 divided by what your T2. Printed on tabra. Remaining mass क्या था? Our remaining mass will be 77 by 5 तारीख को. What is being asked in the question? Question ना हम इसे कहीं ना how much of the gas has leaked out? है बनी ना our leakage क्या है पुरानी से? Tarabang. Man 64 and 80 dog. Known as Hintopio, it should be 63 by 5. We're going to option number 48. Final question में आप तक what क्या है तो का अनुष्ठान को Question number 77. Answer क्या था just by looking at the question से पाप तब ला उठाएंगे को. We have 5 gram of oxygen पीरे में को. At pressure P में temperature T पीरे volume V ले रहे थे को. Then what would be the equation of the motion? Equation of the ideal gas. Ideal gas के लिए क्या P is equal to mass is 5 gram divided by 32 तारवा. And our answer will be equal to your option number 4 तारीख को. Now let us do one last question. उत्तर का विषय. ऐसे खंगोल को. कोई question number can you give an for your question number 77 की वना we have option number 4 as our correct answer because the number of mole will be decided by given mass divided by molecular weight. Yani ko. Next, let us do your question number 75. For this question number 75, the number of oxygen molecule in a cylinder of 1 meter cube volume, 1 meter cube volume at a temperature of 27 degrees Celsius and a pressure equal to 38.8 Pascal, and you should remember that Pascal is the standard unit of pressure. Pressure की standard unit से Pascal दूंता है बा. Then मान अगर हम formula use तो बनी number या को equation लिखना हम ओए अंतर है लो. क्या करता है यार इधर से यार निको P stands for the pressure, B stands for the volume, and N stands for non confusion से क्या देखो pressure कितना पास्कल था सोना कहता है वो पास्कल pressure जो है this would be measured in terms of Pascal and higher नेवा Pascal my standard unit निको ऐसा unit now see Pascal जो तुम्हारे है in terms of another is physical quantity या Newton per force per unit area, force की दी Newton per meter square. And what I am trying to say is that Newton per meter square will be also known as Pascal and course भी आ गया. Confusion से पहले देखो in your question you may find Newton per meter square or you may find Pascal. What would be equal? Okay? ज्ञान ताकत का हंग निको. And what about your volume? Volume से क्या हो रहा है? Volume the usually we consider it as 1 liter, 2 liter and hydra. This is not a standard unit. This is the commercial unit, and for the volume it must be meter cube. Okay. So sina commercial unit like that, and for our then only the standard unit the meter cube hum lakra la. Yeah, ko. Lamana pyramid se kaino here we have to calculate the number of volume. Sorry, we have to calculate the number of molecule present at temperature 27. Hanga niko. Oxygen की हम नत्रा for oxygen molecule कमाई में प्रोपोर्ट करनी हाँ pressure पिरम बरा 13.8 पिरम इको अंदर की pressure जिसे यहाँ की और this is ये की वैल्यू से क्या नो Boltzmann constant तो क्या आता है तो फॉर्मूला बुकते ले गए हम तो Boltzmann constant तो क्या पीगे what is 1.38 I have now 1.38 into 10 to the power 23 1.38 into 10 to the power minus 23 into what is the temperature T1 is equal to 27 degrees Celsius, so it will be equal to 300 Kelvin. Now you calculate the value of N is value calculate 13.8 divided by 1.38 into this is 3 into 10 to the power minus 23. See the Smiley we are set 13 point. Sorry, it should be 1.38 into 300 into 10 to the power minus 23. We can write like this. Okay. सीखेंगे देखो. अगर the for C की conversion की दाखला बनवाने बाद we have this 13.8 into 1 divided by C 0 होंगे की तो लाता है this is 13.8 into this is 3 into we can have 10 to the power 22 minus 22. Do you understand this? यानी क्या 1 0 is utilized for removing one decimal point and another 0 remove one negative power से remove तो रहा यार एको और C cancel से क्या रहा we are left with क्या ना माननी से 1 divided by 10 to the power 22 divided by 3 क्या रहा यार एको तो in short this will be 0.333 3 into 10 to the power 22. Mana kaya period 3.3 to 10. Then this is 3.3 into 10 to the power 21. Dada, start with Laziko. Ayun na, we will start your kinetic theory of gases.